Hi everyone, it's Joe here, and I'm in my house, and my wife and my daughters and my nieces, they're all in the kitchen there listening and ready not to trying not to laugh, but I'll carry on best I can. I'm away learning how to be a good teacher today, so I already thought I was one, but they tell me I need more training. So this is the lesson is Subtraction of Fractions Part 1. And you'll remember from last week when we were introducing addition and subtraction of fractions that they always had to have one condition. And that condition is, this is recall, when adding and subtracting fractions, we must have a, and the answer, of course, is common denominator. Some teachers might say you need a lowest common denominator, and they even do exercises on find the lowest common denominator. But as long as it's a common denominator, that really is all that matters. Okay, so we will go, and I have a few examples of this. This subtraction of fractions to be complete is going to need 2 videos. So as we go along today, there's handouts that match these videos. Marissa or Anne or anybody else taking over for me today will know where they are. And let's get down to the first example. So if somebody's not quite following up to speed, that's okay. Just pause the video for a second, and you can have a chance to catch up. So last thing we did last week was addition of fractions, and there was a package that you got. It was, I think it was 7 pages of all different levels of adding fractions and mixed numbers and that sort of thing. I want to talk about rounding just before we get into our lesson on subtracting, okay? So just take a look at this question and you will remember what these things look like. So 1 7/8 plus 3 2/5 Now, there's more to just being able to crunch the numbers and come up with the proper answer. I want you to be able to get a feel for the numbers. And I want to take a look at the size of these numbers and somehow try and estimate what the final answer will be. And in my opinion, if you can estimate the final answer, it's sometimes even better than giving me a calculated exact answer. Although we need to be able to do both. So this number here, 1 7/8, it's very close to 2. So I just want to go over here and say, let's do it over here. We'll do it, we'll just call that, we'll round it off to 2. I mean, 8/8 would be 1, so 7/8 is almost 1, so this is 1, and almost another whole 1, which makes 2. And this one down here is 3, so it's more than 3 and less than 4. But look at this fraction. This fraction is closer to 3 than it is 4. So let's call this a 3. So if we have 1 7/8 plus 3 2/5, and we just want to get a ballpark value, sometimes having a ballpark value is good enough. So I would say, oh, that's about 2. This is about 3. So our answer must be in the neighborhood of 5. Okay, so I'm going to put that over here. This is an estimated answer, 5. Now let's go in and do the work. 1 7/8, well, I know this much. I'm just going to take the 1 and the 3. I'm going to add them up. 1 and 3 make 4. Now let's just deal with these fractional parts over here. We have eighths and fifths. You know you can't add eighths and fifths. That doesn't work. We need a common denominator. And one way that always works, and we learned this in class, was you take the bottom numbers, the 5 and the 8, and you share them. So watch this, and again, this is a review. We're going to multiply the top up here by 5, and that top by 5. And now we're going to take the 8 from here and use it twice. I don't know if that came out very well on the screen or not, but anyway, this says 7 times 5, 8 times 5, 2 times 8, 5 times 8. Okay, and then from there, I'm gonna rename these fractions. So we've already dealt with the 1 and the 3. That's down here. So 7 times 5 is 35. 8 times 5 is 40. 2 times 8 is 16. 5 times 8 is 40 again. That's what we wanted. That's the whole reason for sharing the denominators. And so what do we have? We have 35 40ths plus 16 40ths. If you have to go over to the side and do it, that's fine with me. Nobody's trying to show off here at all. So 35 plus 16 is going to be 51. So what do we have? We have 4 and 51 40ths. But we see there's a problem here. 51 40ths is an improper fraction. It doesn't fit. It's correct, but it's not acceptable as a final answer. So let's take a look at this 51 40ths for a second. And you remember that in order to turn this part here into a mixed number, you see how many times does 40 go into 51? Well, 40 goes into 51 one time. And how many left over? Well, 40 goes into 51 one time, and if you do the division, it's 11 left over. So 11 what? 11 40ths. Okay, so here we have it. We have this 4. I'm going to put it in a box. We just got that from these guys over here. That was the easy part. And then this blue box over here, we've got 1 and 11 40ths. So what am I going to do? I'm just going to put these two together, and that's going to give me 4 plus 1 is 5, and 11 40ths. And that is my final answer, 5 and 11 40ths. Okay, and one final comment. Take a look at 5 and 11 40ths, and then go over and look at our original estimate. Well, they're pretty close because 11 40ths is less than half. If I had 20 40ths, that would be a half. Then I'd have 5 1/2. But this is not 20/40ths. It's way lower than that. So that means this fraction here, this mixed number, is closer to 5 than it is 6. So our estimate was well done, and our final answer makes sense. All right? So pause the video for a second, and I will move on to the next part. Good. Okay. So I want to talk about the concept of 1. And again, this is a reminder. I've told some of my classes that I could teach for 2 months on the number 1. So let me show you what I mean. The number 1, that number, the whole number 1, we make that number whatever we need it to be. What do I mean by that? Well, you know what? Sometimes I need it to be 3/3. Okay, that's good. What about what if I'm not dealing with any thirds? What if I have sevenths in my question? Well, then 1 can be called 7/7. I could even go so far as to say 178/178. So anything over itself is equal to 1. And there's one exception. The exception is this. 0/0. There's no meaning to that. You can never have anything over 0. And as you get into higher grades, they can prove that to you. But right now, I can't prove that to you at this level. Okay? In this case, you just have to trust me that there's no meaning behind this. So, here we go. Whoops, my music stands are falling. Let's subtract. A. 11/12 minus 4/12. Well, the first thing again that we look for is that the denominators are the same. And there's a 12 there, there's a 12 there, all is well. All we have to do now is subtract the tops and rewrite the bottoms. 11 minus 4 is 7. 12 and 12, we're not subtracting them, we're just comparing them, and they are in fact 12, and that's good. There's nothing else to do. 7/12. Here we go with B part. B part says 13/16 minus 5/8. So 13/16 minus 5/8. Okay. We've got a 16. We've got an 8. They're different. Can't work with those. Now, in this case, the lowest common denominator, or a common denominator, is already buried in the question. So let's look at the bottom of the lower number here, this 8. Now, can we turn that into a 16? Yes, we can. That's what I mean by having the common denominator buried in the question. We can turn 8 into a 16 simply by multiplying by 2. So I'm going to do that. I'm going to multiply this by 2. I'm going to multiply that by 2. Whatever you do to the bottom, you do to the top, and vice versa. And now I'm going to rewrite my question so it's a little bit cleaner, and I'll do it in blue. So 13 over 16, subtract. Okay, what did this thing over here become? It became 10 over 16. They're both the same now, 16ths. So 13 minus 16th minus 10 16ths is equal to 3 16ths. That is our final answer. And always make sure when you get a final answer that that final answer is reduced. Okay, so if this, for example, was a 4 16ths, well, you'd have to reduce it. But 3 16ths, it's as far as you go. You can't reduce that. Okay, so one more example. So I'll have a C example coming up on the next board here. So just 1 second. I think I'm gonna have to get rid of that dingy thing up there. Okay, here's the question. C is 3/8 minus 5/24. So C question, 3/8 minus 5/24. Okay. Well, you've got 8ths, you got 24ths. Again, I buried the common denominator in the question. How do let's take the smaller denominator and try to make it into the bigger one. Okay, so what would I do? I take the 8, I need to make it a 24. Okay, 8 and 24, well, if I multiply by 3, I can turn my 8 into a 24. So that's what I'm going to do. So I'm going to multiply this by 3, multiply that by 3, and I'm going to rewrite it down below. So what does that become? Oh, 3 times 3 is 9. 8 times 3 is 24. Okay, that's good. We're on the right track. That's what I want. Now that's already in the form we want, so that's okay. So there we have it. We have a new question with the same answer. 9/24 subtract 5/24. So they're both 24 on the bottom, so the answer has to be 24 on the bottom. And what do we have on the top? Well, 9 subtract 5 is 4. And 4/24 is a correct answer, but it's not complete. If there's two even numbers, they're obviously divisible by 2. But in this case, let's not bother doing that because we're going to end up with 2 more even numbers. But we can see that the top is divisible by 4 and the bottom is divisible by 4. Okay, so this answer here will get you 2 out of 3 on a test. 2 out of 3 is not bad, but let's go for 3 out of 3. So I'm gonna reduce this. That's what R means. Whenever you see R on your papers, you know that you forgot to reduce. So 4/24 is equal to 1/6. And there's your final answer. Okay, so those should be in your notes. Have them there. refer to them as much as you need. And on the next video, I'll finish off subtraction of fractions and include mixed numbers, and we'll look at a little bit of estimating as well. Okay, so we shall see you in the next video. Bye.